All right, so we're going to be doing data scraping. If you don't know what that is, that's just literally taking data from anywhere, like a file or a website, and then putting it into a format that you could use. So not always can you just use what's on the website. Usually you have to do some code magic on it before it'll actually work. So that's what we're going to do. You'll want to use Python because I think you could do this in R, but it's not as easy. And in general, I think a lot of people are using Python. If you're not, this is how you download it. You go to this link right here, and there's going to be a download button. It's going to be like yellow right here. So you just download that and you go through all the steps. So in case you don't have an editor, make sure to get one of those too. I recommend Visual Studio Code because most people are using that in their classes, like Intro to Comp Sci and all that. So you can get this one. Some people in data science also use Jupyter notebooks, but I think everyone has VS Code, at least to start, so I'm going to be using that one. So yeah, just when you download Python, if you don't have it, just install it normally. Keep everything checked, just what's already checked, especially pip, just make sure that's checked. And again, just keep everything that it automatically checks checked, and then you can install it. So to make sure you have it installed, if you just want to really be sure and you want to check, just go to your command prompt and then type Python. It doesn't matter what folder you're in, just type in Python -- version, and it'll tell you what version you're on. So hopefully something comes up here. That means you have Python. If it doesn't show up anywhere else, that's fine. It just has to show up here. So that means you have Python. Now, what we're going to be doing is just to make sure that everything works and you don't get any weird folder errors, just make a new folder to store all your Datathon code in. Unless you have one already, which just in that case, just use your own folder. Then you open it in a code editor like VS Code and download the 2 following PDFs into that folder. So I'm going to show them on the next slide. This is the first example we're going to be using. So it's just a basic table from a website. It's literally a PDF with a bunch of science experiments, and I thought this table was pretty generic. So we're going to try it first on this PDF. So I'm going to just send this in the chat for everyone. And make sure to just download that and move it into your folder. So I have a folder, it's in my Python, and it's called Reading PDFs. It doesn't matter what folder it is. It could just be anything. Then next, this Dunkin' Donuts dataset, you're going to want to download that as well and add it to the folder. So yeah, this is what it looks like. If anyone has tried scraping this before, it's probably not going to come out perfect because of this. The column names are vertical, so it's going to be a bit weird. And also the tables are separated. So these donuts are part of the same table as these donuts, but they're on a different page, which the scraper doesn't really, any libraries that you use, they don't really account for that. So we're going to fix that problem. Yeah, so just make sure you have that downloaded. And what we're going to be doing is storing it either in a pandas data frame or into a CSV file. So whichever one you want. If you're using Python, it might be nice to keep it as a data frame. If you're using R, then you might want it as a CSV. So now your folder should look like this. It's going to have a PDF with the Dunkin' Donuts data and one with the example data. Yeah, just these two files. And next, you're just going to make a random Python file inside this folder. And you're going to be doing your code in this file. The reason why you want to have them all in the same folder is just to make sure that it recognizes the PDFs and that you don't have to type in some long file path to find them. If they're in the same folder, you could just say you want to read from nutrition.pdf and it'll work. That's what your folder should look like. And now we're going to scrape data from PDFs. So the library you will want to have is not Tabula, because even though Tabula is what most Python people use to read tables, it's not actually going to work with this PDF because this data isn't actually encoded properly in a recognized encoding. It's literally just a picture on a screen. So it's not going to be recognized by any program like that. The only way to read it is to find a Python library that recognizes images. And the one that does that is called pdfplumber. So pdfplumber, it extracts text, data, and images from PDFs, and it does it pretty well. So if you want to install that, just go into your terminal. It could be your VS Code terminal or your just normal basic computer terminal, and type pip install pdfplumber. And that should install. So yeah, that's the first thing that you'll need. Then you'll want to download the pandas library. I feel like a lot of people have this already, but just in case you don't have it, do pip install pandas as well, because this is the library that you usually use to analyze data. It has a really important feature, which is called Dataframe to CSV. So whatever magic you do on the data, you can just convert it to a CSV file, which can be used basically anywhere. So usually pip install stuff pretty fast. It's not going to be that long. If you want, you could also just type it into the VS Code terminal. You could just type pip install pandas here and it'll also work. Just make sure that if you're doing this, that you're in the folder that you're going to be using, because I'm pretty sure if you're not in the folder, then some weird stuff might happen. It's happened to me before. So just make sure that if you're doing all of this in a folder called reading PDFs, you're in that folder before you do pip install. That might help you avoid some errors. All right, then the next thing is we're going to talk about a pandas data frame. So that's literally just what a table should look like. It'll have rows and columns. And this is what we're going to be working with. That's how Python, this pandas library represents data. Okay, so we're going to go over the code now. So we import that library that we just downloaded. It's called pdfplumber, and we're going to use it to read the data. Then you import pandas, and we're just going to refer to it as PD as a shorter name to call it. So pandas is the thing you're importing. Later in the code, we're going to call it just PD. So type import pandas as PD. And then we're going to first do the example. So we're going to read whatever that example PDF was. I just called it table.pdf. If you called it something else, then make sure to type that here. Then after you have that, you specified the PDF path that you want to read. Now we're going to store a list of all our data frames. So when we read the PDF, what's going to happen is that's going to take every single table in the PDF and store it in a list. And that's going to be this list right here. Then this piece of code just opens the PDF with pdfplumber.open, then this PDF path is going to refer to whatever you had here as your PDF path. Then you're going to use this like Python function called enumerate, where it's just going to go through each page, keep a count of what page you're on, and it's going to extract all the tables. So it's going to store every table on that page into a variable called tables. And then for each table, it's going to make sure that table exists, and then it's going to create a data frame out of it. And the data frame is literally just the Python representation of what a table should look like. The pd.dataframe function, when it reads a table, the first argument is going to be the data of the table, and the second is going to be the column headers. So this is going to decide that when we read the PDF, the first row of the table is just going to be the column headers. Like we have here, name, team, number, position, age. These are going to be the column headers. So that's what this is doing. It's deciding what's going to be the column headers and what's going to be the data. Then we're going to add it to our list of data frames. Now, this code down here, you might not really need, but just in case it doesn't work, you want to print that an error occurred and what page it occurred on. But luckily, this code will work on the examples, so there's not going to be an error. You might not need this piece of the code. All right, okay, so I'm also going to show this later, and tomorrow it'll be on YouTube if you want to look at this again. But this is going to be the example code that's going to read that scientific experiment PDF that you just downloaded, and it should work. Now, in order to actually see what data we extracted, you'll want to go and make a function to print the data frame. If you don't want to print the data frame, then you don't have to make this function. What you can also do is make a function to convert the data frames to CSVs. So this function is literally just going through every data frame, every table that you extracted from the PDF and converting it into a CSV. So I'll actually show this in the editor here. Yeah, so I just ran the code by typing in python reading.py because the name of the file I made is just called reading. So it converted every table in the PDF. This is the PDF. It's just these three tables with a bunch of column headers and then data like normal. So it's going to go through each table and print the data. And that's what it did. So it has the comma separated values. It's just the data, the pure data, and then commas. So that's what the data frame to CSV function does. When you're doing the Datathon, you might want to name it something a little bit better. Like you might want to go into the actual PDF and maybe find what the drink is called and then name it after what the drink is called. But here in this example, we're just naming it table00.csv. Okay, and that's using the data frames. It's taking the list of data frames and then finding the data frame that you want. So if you run data frame to CSV of 0, it's going to go to the first data frame in the list of data frames and then convert that to a CSV. So that's what it does. It runs on a data frame. Yeah, so it works on that example file, but if you try it on the Dunkin dataset, it's not actually going to work perfectly because the data will look all right, but when you read the column headers, they're going to be reversed. So they'll look a little bit jumbled. So in order to fix that, you'll have to first reverse these column headers, and then you're going to have to get rid of the new line characters that's recognizing. You're also going to have to get rid of the new line characters in the drink column. So if you want to see that, let me first change this nutrition.pdf. So if we try to run this code on Dunkin' Donuts file, it's going to take some time, and then it's going to go through every single page in like the 51-page PDF and extract every single table. So it'll look like this. It'll have a bunch of new line characters in the first column. It'll have reversed column headers, and it'll have a bunch of new line characters inside the column headers. And that's because it's reading each line one at a time. So it'll just read the first line as E, then Z, then I, then S, which will get you easy IS. It'll reverse the characters. So while it's happening, there's going to be another problem, which is that donuts, this table is donuts, but it's split onto 2 pages. So not every table will be just fit onto 1 page. And you can see that there's a lot of examples of this. The PDF, the Python library, when it reads these tables, it's going to look at it as 2 separate tables. It's going to think this donuts is 1 table and this donuts is another table. So it's going to end up putting them on different. If we go to table 02.csv, it's going to say donuts. It's going to have all this data. And then table 03.csv is also going to have another donuts table. But we would rather just have it all in 1 table. So there are 3 problems so far to fix, which is that for every data frame, you'll want to reverse the column header names except the first one. So not the first one. The first one will be just the name of the category of the drink. So that'll be completely fine. Like you don't have to reverse croissant stuffers. You don't have to reverse cold brew coffee. Everything else is what you'll need to reverse. As you can see, this column header is completely fine, cold brew coffee, but the next one is size/serving, and it's backwards. So that's what you want to fix. Then for every data frame, you'll want to go into the first column and then replace each new line character with a space. So your pdfplumber library read a lot of new lines when it wasn't supposed to, and that's going to mess up your data a little bit. So you can get rid of that using some pretty like available Python code. If you just search up how to get rid of new lines or how to reverse a string in Python, that will be pretty easy to find. You're going to have to use the df.columns function just as a hint to reverse a string. So you're going to have to go into the df.columns because it'll give you a list of every single column in the data frame. That's how you'll be able to reverse them later. And then for the second problem, you want to learn the pandas df.ilock function. So the df.ilock function will allow you to locate a specific column or row in the data set and then manipulate it. So if you use that, you'll be able to get rid of all these new line characters. However, the last one, I don't think it's easy to find on your own. So I'm just going to show that one to you, which is group the data frames together that all have the same name. So in the case that we have multiple files where it's showing the donuts table, we want that just to be grouped into one file. Like obviously there's not 99 different tables in the Dunkin' Donuts dataset. There's something more like 50 or 40. So we're gonna really want to apply this so that all the data is grouped into what it should be. We're not supposed to have an iced coffee table here and then another iced coffee table here. So to fix this, you want to group the data frames that have the same top left header. This here, iced coffee, is the top left header. There's also a comma before this, so you want to make sure that it's the first non-empty header. So if a file has iced coffee as the first header, and another file has iced coffee as the first header, you're going to want to make sure that they're all counted as one data frame. So to do that, I need a separate file called reading2.py. And we're going to use this function. It's going to be called first non-empty header. So this is just going to find the first header in our data frame that isn't empty. So it's going to be the top left. The strip function is just used to make sure that it's taking off the spaces at the ends. So if this function works, it should return the header, the first header that isn't empty. If it is empty, it's just going to return none. Or it's not going to return none, it's just going to move on to the next header. So if you run it on this data frame, it's just going to give you donuts. And if you run it on this data frame, it's going to give you donuts. So we have that function. Then we want to make a dictionary called group dfs. Now, in Java, this is like a hash table, but in Python, it's a dictionary. It's just two brackets next to each other. So this is going to be all our grouped data frames. So for every data frame in our list of data frames that we gathered earlier, right here, we're going to take its header, its first non-empty header, and then we're going to check if that header exists, and if it's not in the group data frames, we're going to make it into its own group. And if it already exists, then we're just going to add it to whatever group it belongs to. So what this code will do is it'll make a list for every group of data frames that has the same top left header. So the cold brew coffees and the iced coffees and the donuts, they won't be separated. They'll all be in the same table. And now we're going to use a function called pd.concat. So first we're going to make a list of our concatenated data frames. It's going to be empty, but we're going to use it. So we enumerate we iterate through all our grouped data frames, and we use pd.concat to concatenate the groups together. So everything that's in the same group will be concatenated into one data frame. And then once we do that, we add it to this empty list. So yeah, this part is not something you learn like early on in Python, and it's not really used that often in pandas, but we'll have to use it to get this to work, this specific PDF, just because of the fact that that data tables overflow onto separate pages. You'll want to group them together based on if they share a header, if they share like the category. And once you do that, you group the ones that have that same header, and then you concatenate the groups together. So now instead of 100 different tables, you're down to like 47 tables where all the ones that have the same header are just grouped together. And now you add it to this list called concatenated DFs. And the last part is that you take your list of data frames and you just set it equal to concatenated DFs, because now this is what you want to use. You don't want to use your old list of data frames that has like 100 separate tables all in a list. You want the new and improved version where everything that shares a category is now together. It's all grouped into a table. So your new list of data frames it'll have way cut down the amount of tables. So yeah, if you don't get it like immediately, that's okay. The pd.concat function only works in certain situations, and this is only one of those times. So it's good to go over it and try to understand it. So also, I have this mystery function that's going to fix all the column names. It's going to do it's going to fix those two problems right here. It's going to reverse the column header names and replace each new line character with a space. And then it's going to go into the first column with the drink names and replace all the new line characters with a space. So it's going to fix that data. I can't show it to you because if I did, then everyone would have the answers already. But this is like a challenge part of using the Dunkin' Donuts data set. So that's a little bit easier to find because you could just Google it. But this one, you want to make sure that you know how to do it to group the data frames together. And then right here, we have the same functions of fixing the column names is a new thing that is going to fix all the column names and unreverse them, then delete all the new lines. Then it's just going to convert every data frame to a CSV. So first, before we generate those new tables, I'm just going to delete all these old tables. So that they're not in the way. And then open up VS Code again. And now we're going to run reading PDFs. So this new file is going to take the Dunkin' Donuts data set, and it's going to do the same thing we did last time, which is extract all the tables. Then it's going to take this function first non-empty header, and it's going to use that to find for each data frame what category it's in. Then it's going to use that category name to group all the data frames that should be together. And now we have grouped DFs. Then we're going to use this grouped DFs dictionary to add up together all the data frames that should be added together. That way, eventually, this donuts table and this donuts table will all be included in the same table. They'll all be together in one CSV file. So here I just had it print how many data frames there were, and it shows that there are going to be 48. So the first one will have cold brew coffee, and as you can see, the column names are good now. They're reversed and the new lines are gone. So you'll want to figure out how to do that. And what's changed here is that every new line character is removed from the drink names. So that's the second thing you're going to want to do. Caramel cold brew with sweet cold foam. There should be no new line characters, which is \n in this name. Then we have croissant stuffers. Donuts is now all in one table. So before, we had this vanilla frosted with Valentine's sprinkles donut, like included in a different file. But now it's just included in the same file. And this is a new table that starts on the next one. So each CSV file will now have a whole different category. And that's basically what we were trying to do the whole time. That's basically, there's these hints. If you want to complete the other two, we did number 3, but number 2 and number 1 are the problems you need to fix to make this code work for the Dunkin' Donuts dataset.